Hello, hello, hello. What is up? Good. Alright, I think I need to check my audio is bad. Now it's much better. The audio on. Okay. You guys ready? So the plan for today is we're doing what? A paper 4 question. Let me just announce it on Noon Academy that we have a link, that we are live. I really like this blue. No, stop. Okay. Warrior 1. Do I hear something? Okay. You guys can't hear the fan, right? Okay. Okay now. I'm very concerned about the sound. This is done, right? Okay. We are live. How many people are watching? 12 people already. Hi, Ritesh. Hi, Haras. It's theory, Haras. This paper 4 is theory. For those studying O-levels who don't know, who might just be a bit confused, let me just talk about it. In O-levels, what we have is, in O-levels, you have paper 1, which are MCQs, paper 2, which is your theory, paper 3, which is your practical, but no one takes that, and paper 4, which is your ATP. For IGCSE, now IGCSE has 6 papers. It has P1, P2, P3, P4, P5, and P6. Now these 2 are MCQ papers. These 2 are theory papers. These 2 are, I think one's practical, one's ATP, right? Now for paper 1 and paper 2, the difference is one is extended. That means it has more in the syllabus, extended, right? And one is just core. So core is like just has your basic chemistry. Extended has a little extra, right? So most people do extended. So paper 2 is extended. So this would be MCQs for, you know, paper 4 is also extended, so this is theory for IGCSE, right? So kind of like paper 1 is kind of like you want to look for paper 2 for IGCSE if you want that extra practice. Paper 2 theory will be doing paper 4. And for paper 4, ATP will be looking at paper 6. I haven't shared the screen on Zoom yet. I knew I was forgetting something. I'm sorry. I'm sorry. Sorry. Okay, my bad. But I'll just repeat. Paper 1 in O-levels will be doing, if you're looking for extra practice for MCQs, we'll be looking at paper 2 for IGCSE. Not paper 1 because this is just the core MCQ paper. So it's a little easier. Paper 2 is more challenging. So that's what we're focusing on. But if you can do this, you can definitely do paper 1. So yeah. Anyway, so paper 1 for O levels, look for paper 2 for IGCSE. If you want some extra practice, you can look for paper 4 in IGCSE, and so on and so forth. Okay, with that, we can move on. We have exams in some weeks. Okay, good to know. Let's try our first question while I take a first sip of my tea. Question 1 is very straightforward. Question 1 is straightforward. The tea has a bit of a, I think they just put a pinch of coffee in it. I hope we can do one complete paper today. But I'm barely starting. I don't have room. And I'm complaining, and I'm complaining. Okay. Name the element that can be used as a fuel. Now, if you're thinking carbon, you're absolutely right. I would go with carbon as well. Is this a little thick? Yeah. Carbon is completely fine, but you can also talk about hydrogen being a fuel. Now, hydrogen, I'll just highlight, can be used in your fuel cells, right? Hydrogen is also used as rocket fuel because it combusts, gives out a lot of energy. And yeah, so these two can be used as fuels, are used as fuels. Name the element that forms an oxide with a similar structure to that of diamond. I can only think of one thing. What is that one thing? I can only think of silicon dioxide. Right? Forms an oxide with a similar structure, but we have to highlight an element that forms that oxide which is similar to diamond. So we're not highlighting silicon dioxide, we're highlighting silicon. Name the element that forms an amphoteric oxide. My favorite is, I don't know if you guys have a favorite, is aluminium. Name the element that has an oxidation state of +2 and +3. Now some people, like I think Miral, Hanan, you might find this slightly tricky because it's more to do with our salt analysis, but we'll take care of this real soon. But you might already know this because you guys are really smart. But what they're looking for is iron, because iron has multiple oxidation states. Iron can exist with an oxidation state of 2 and 3. Or in other words, it can have variable charges. Either it could be a +2 or a +3, right? So how does that translate to real life examples? So iron chloride could either be FeCl2 or FeCl3, if that makes sense to people. Let me just move this a bit here so it's a little more clear to see. Tika, with me so far? Everyone's with me? I think I just went on a little fast. That's good, right? Yes, straightforward, but I think question 1 we can speed through because it's very straightforward. Tika, name the element that's extracted from bauxite. Oh, how I know bauxite. It is aluminium once more. Name the element that has an atom with an electronic structure of 2,6. If it has an electronic structure of 2,6, that means it has 8 electrons. If it has 8 electrons, that atom would have 8 protons. What would have 8 protons? I checked the periodic table real quick and I confirm if it's present over here. Yes, it is. They're talking about oxygen. Easy? Easy? How many of us are getting full marks? 1, 2, 3, 4, 5, 6. Look how pretty that looks. Is that me or it is me? Something is not right. Oxygen. My laptop is Depleting energy. Something is wrong. Oh well. Right? Shall we move on? Full marks? Great job, Meral. Let us move on. Iron rusts when it is in contact with oxygen and water. Explain how sacrificial protection prevents rusting. How does it prevent rusting? Just going over my paper as well. Should have done it somewhere else. Essentially, it's asking, can you talk about sacrificial protection that prevents rusting of iron or anything else? And how do we answer this is, essentially what's going on is there are metals which are highly more reactive than iron. If you put them next to iron, like touching each other, between iron and the more reactive metal will oxidize or rust. And so in essence, it ends up protecting iron. So you see this a lot, or the example, you don't get to see it, in the hulls of ships. Ships are normally made of steel or iron, and what they'll do is they'll put small pieces of higher reactive metals on it. So once it's rusting, they want this metal to rust first, then the entire ship. But before this entire thing rusts, they replace it with a new piece of metal. Normally the metal they go with is magnesium or zinc. Okay. How do we phrase this? Okay. Let's try going for metals higher in the reactivity series. Such as, oh well, let's write the full thing. Zinc and magnesium. Can't see the dot there. It doesn't look good. What would suit this blue color? I think this pink. Will rust or oxidized? Will be oxidized in preference to iron because they are more reactive, but I already said that. In preference to iron. A lot of us pronounce this word, even I make that mistake pronounce this word incorrectly. We try to say iron, but it's actually iron, where the R is a bit silent. Just letting you guys know if you want to be, fancy about it. State one other method of rust prevention. Now this is a little confusing. They want another method of rust prevention that does not involve sacrificial protection. Now, some people might say galvanizing, and that's kind of hard to understand from this question. What you could essentially do is prevent the iron from getting in contact with water. The best way to do that is coating it completely. So you can say electroplating, or as most commonly we see, you can even paint iron. And that prevents it. You see a lot of metal gates are just painted. Why is galvanizing wrong? You guys remember what galvanizing is? Galvanizing. That's also a form of protection. But galvanizing is very similar to electroplating and a mixture of the sacrificial protection. What they do is they end up coating the metal, electroplating the metal with something like zinc. So not only does it coat the entire metal, preventing it from oxidizing, but if there's like a dent anywhere and that part is exposed, all that zinc around it will do its sacrificial protection and protect whatever's on the inside. So that's galvanizing for you. But galvanizing is not accepted because they want a method of protection aside from sacrificial protection. which is not clearly understood here. Like the question is a bit ambiguous, but I hope everyone gets it. Let's take a oiling. Oiling, yeah, that's difficult. Oiling, oil doesn't stay in one place. It's just, you don't coat the outer body of a car with oil, right? Oil is, I think it's best of both. Like you kind of apply oil on mechanical parts, so it protects it, but more importantly, it's meant to be there to prevent, to encourage slipping, right? It's a lubricant. That's why you use oil primarily. It's secondary. Oiling would be like a secondary thing. Like it's a good, happy accident that it protects iron from rusting as well, like bike chains. But the entire bike is coated with not oil, but it's painted, right? To protect it from. I'd call you out. I'd give a shout out, but your name is so weird, I just can't. But you're welcome for this. Yeah. Okay, let's move on. Zinc is extracted from an ore containing zinc sulfide. This we didn't talk about. So that ore, what they're referring to, which is primarily zinc sulfide, is called zinc blende. But let's take out a nice color. I say nice color, but I choose this. It's called zinc blende. The ore, aluminum comes from bauxite, iron comes from hematite, zinc comes from zinc blende. It's just the name of the ore. Oil can be washed away. Yeah, it's not there permanently, right? You know, Fatima. Yeah, so it's not a protection per se. Like, you don't oil the body of a car, you get it painted, right? So it's not really there for protection purposes. Oh well, let's move on. This ore is converted to zinc oxide, the ore zinc sulfide. So I'm guessing it's ZnS2. Not guessing, pretty much is. This ore is converted to, oh, will it be S2? I think ZnS, yeah. The ore is converted to zinc oxide, ZnO. Zinc oxide is then reacted with carbon. Where are they going with this? Write a chemical equation for the reaction of zinc oxide with carbon. Chalo, bismillah. Bismillah. Okay, zinc oxide with carbon. Very reminiscent of what equation? This is a metal displacement equation they're referring to, and you'll form carbon dioxide and zinc, right? And to balance it out, to put a 2 here and a 2 here. Easy? Zinc ore is not in the O-level syllabus. IGCSE has it. Yes. I should have specified. Alan, do you take IGCSE or O-levels? ठीक है. State what type of chemical change happens to zinc in zinc oxide in this reaction. What's happening to zinc? Someone tell me this. I won't answer this until someone gives me a reasonable answer. What is the best word to describe what's happening to zinc? Reduction. Absolutely. Now, where is Messam and everyone else? Oh, is it too late? Is that why Messam isn't here? I miss Messam. Reduction. And how do we know? Loss of oxygen is how I know. That's a horrible. Let's just go with white. Loss. I forgot how to spell loss. 2 S's, right? Loss of oxygen is reduction. Mohammed Junaid, reduction. Why you say sorry? Oh, you said oxidation earlier. He's okay. He's okay. Explain why aluminum is not extracted from aluminum oxide by heating with carbon. Why? Do we know why? Because aluminum is... Ow, my wrist. Okay. I want a good color, of course. And that's not a good color. Aluminium is more or higher in the reactivity series, is more reactive than carbon. Or I think it's better if I say carbon is less reactive than aluminum, because my next line makes sense more logically that way, because I'm going to say therefore, or I should say therefore carbon cannot displace aluminium from Al2O3. Suggest an alternative method of extraction of zinc if you cannot react it with carbon, reduce it with carbon. And the answer is, ladies and gentlemen, electrolysis. Very easy so far. Don't you guys think so? It's very easy. Very, very easy. How very easy? Please explain more about the reduction one. Neha, can you ask your question completely in full sentences so I know exactly, because I missed out what you were referring to? I'll come back to this question once I have your question. For now, I shall move on. Okay. This was slightly difficult for me to answer. I struggled for it for a bit. Brass is an alloy of zinc. Brass is actually copper and zinc together. Explain in terms of particles why brass is harder than pure zinc. Especially people who are watching, I'd recommend practice this out. What would be less reactive? Okay, anyway, practice this out, but meanwhile I'll answer it. Okay, I want to start by describing metals are actually in layers. Can I change this yellow? As much as I love it, I don't want to repeat my colors. I'm running out of colors. Metals are, or not are, have layers. Ogres have layers. Like cake. Metals have layers which can slide over each other, making them, give me a second. One minute. Making them, what was I saying? Making them malleable. Can someone tell me how to spell malleable? I'm gonna guess here, malleable. Bet the word's French. I always have difficulty spelling it. In brass, copper and, I'll say copper, I would have written it down, but my wrist started hurting really bad right now, so I'm just going towards elemental symbols. Copper, I should not slouch either. Copper and zinc have different sized cations positive, right? That make it difficult for the layers, sorry, my handwriting is, for the layers to slide over each other. And I look up each other, I'm going to look up and look for Binte's question, which I promised her to answer. Regularly arranged layers which can slide over each other, whereas brass is an alloy which disrupts the regularly arranged layer, making it hard. That's better explained by Abdul Ghani right now. I think I said someone else's name, but Neha hasn't asked her question again. So let's move on. Okay. Does this make sense? Can we write a displacement reaction? Miral, sorry, I didn't read that earlier. Which part are you referring to? This one? B part 1? B part 4? You can't have a displacement reaction because you already did it. Essentially, this is a displacement reaction. But can you? No. You cannot talk about another displacement reaction. Because, yeah, I think I completely understand what you're saying. If not for carbon, they're not saying, let's read the question. Alternative method, not an alternative substance. So method needs to be different. If carbon is done through the displacement thing, right? So yeah, they want a different method. They were looking for electrolysis. Whenever confused, try making sure. Yeah, you got it, right? But whenever confused, like the question before this was really tricky to find out what exactly they wanted to hear, or like they wanted us to answer. So yeah, just try thinking as an examiner for a bit. Like, what do I want to ask the same thing, or do I want to be a little more complicated? It didn't come on your email, Abdul Ghani? The Zoom link? I put it on Tribe. You should have been able to get it. It's still on Tribe. Try the same link. Should I post it again? I'm sorry about that you didn't get it. I was meant to post it. Copy link. Let's try. Okay. Sorry. Zoom link and post. Post without topic. No, post. I said post without topic. Notify everyone. Sorry. Pitching. Okay. We shall move on to this question, where you shall balance this equation and I shall have some chai. Actually, I think it was a good choice. I didn't turn my camera on. I think my video would have been blocking the screen because there's just so much text here today. Part B, I really like. Where'd my pencil go? Part B, I really like because it's so easy. The 2 nitrogens over here, so there should be 2 over here, right? And 2 sodiums here, those should be 2 over here. And on closer inspection, I have 8 hydrogen over here and 2 over here. That's a total of 10. 6 here, so I need 4 here. Easy. Is that correct? And it looks correct. 2.8 grams. 2.8 gram sample of impure ammonia sulfate. Hang on, let me go back to YouTube. That's my charging. Oh, okay. Hmm. 2.8 grams of impure ammonium sulfate is found to contain 0.7 grams of impurities. Calculate the percentage of ammonia. These are the impurities. How much of it is pure? 2.8 minus 0.7. So the pure amount is 2.1 grams, the subtraction. The total amount is 2.8 grams. So that's 2.1 over 2.8 times 100, 75. Describe a test for ammonia. Those who are struggling and have been following us, don't be too confused because we haven't really done this, but who doesn't know about ammonia, right? Ammonia gas, the test is damp red litmus paper. Bring that in front of it. Okay, because it's alkaline, the gas is alkaline, it'll turn blue, right? I like this question because it's easy, but I hate this question because it's a little too easy. Do you guys agree? Name the process that occurs when ammonia gas spreads throughout the lab. Diffusion. Explain using ideas from about particles why ammonia is a spread. So 2 marks, I'll say 2 points. Why? Because my hand hurts. Sorry, but I shall only answer 2 points. Particles are always in random motion. Gas particles. Particles are in random motion, which, okay, not this pink. What goes with this yellow? I have my priorities in order. Particles are in random motion. So they end up moving because of this random motion, because of this, they move from a region of higher concentration to a region of lower concentration. Carbon dioxide. Because it is heavier than ammonia. Hey, Rouge, what's up? Small Mr. Small MR. Yeah? Okay. Very, yeah. Okay. Oh, well. Oh, we're continuing. Haber process shows up. Okay. In the Haber process, a temperature of 450 degrees Celsius and a pressure of 200 atmospheres are used in the presence of finely divided iron. A large equilibrium yield of ammonia would be produced if a lower temperature and a higher pressure is used. Let me read the entire question. Ammonia is produced. Okay, equation. Okay, there's no other part. Okay, they're telling us because of these reasons. Explain why a lower temperature and a higher pressure are not used. Why is a lower pressure not used? Lower temperature is not used. Now, equilibrium, the yield will be higher of the equilibrium, but the time taken to reach that equilibrium will be way longer because the rate of the reaction is lower. That is the specific answer for the Haber's process. Why we use lower temperature. Because, right? Now, some people might find this really challenging to understand. Oh, look, rate is higher, but the equilibrium is less. What? Like, shouldn't it be more? Imagine a seesaw. If it stops moving, let's say this is its equilibrium position, right? And if you hit it, it could work in two ways, depending on, let's say, the temperature of the seesaw. I'm joking, but depending on different conditions, it could oscillate really quickly up and down really quickly, right? And reach equilibrium very fast. Like maybe it does like dot, 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 and done. It's in equilibrium, Or it could be one of those seesaws, like you see in scary movies. They keep going. Why am I doing that? Right? And they keep on doing it. It'll take it days to kind of like reach this equilibrium. It'll keep on doing it back and forth, back and forth. So that's a slow rate. So you understand every day, it doesn't reach this equilibrium. Think about this reaction something very similarly, right? If this reaches equilibrium really fast with higher temperature, you can just take that ammonia out and make it reach the equilibrium fast again and take that ammonia out over and over again. So your quantity of ammonia produced per day is much higher. Okay? Miral, are you laughing at me? Because of that mimicry I did because of the seesaws? Okay, let me just... I'm so sorry. Okay. All right. Miral's not even like nice about it. Like, yes, I'm laughing at you. Okay, chalo. Explain why a lower temperature and a higher pressure. A lower temperature is favored because the rate of the reaction is higher. Higher rate of reaction, I'll just say. Higher rate of reaction. I hope everyone understood that seesaw example. I went off on a limb and embarrassed myself doing that seesaw impression. But hey, if it's funny, you guys remember it, right? That's how the world works. Higher pressure, why is that not used? Now note, higher pressure will favor the reaction to the right-hand side. But higher pressure uses a lot of electrical pumps. Electrical pumps use what? Electricity, resulting in the cost of ammonia being more expensive. So you can just get the same amount by using a lower pressure. So higher pressure will increase the expense or make ammonia more expensive. Expense. Yes, how does this green look? Very readable. State the role of iron in the Haber's process, I ask. What time is it? 9:44. Oh, we're not doing too badly. It is a catalyst. Catalyst? Yes. That's how you spell catalyst. State the role. Okay, I'm reading this. Explain the meaning of the term base. Now, we didn't talk about this, I feel. I think we never did. But do you guys know the meaning of a base? But we did. We were doing that question and I was talking about proton donors and proton acceptors. And a base is essentially a proton acceptor because it reacts with... Acceptor has a O in it, right? Okay. And because why? Because this is what they're referring to as a proton. The H+ ion. Anyone on YouTube snickering because I did that seesaw impression? Okay. Miral, Hanan, does this make sense? Yes, straightforward. pH of ammonia, I'll go with 10. right? It's a weak base. Oh, okay. Why is it a weak base? Because it partializes ionizedly. Should we just guess? The acceptable answer is from 8 to 12. Knowing that it's a weak base, you can go with any number. But 9, 10, 11 are good numbers, you know? Watch for amazing videos, says question mark. Yeah. Yeah. Let's move on. I can't wait for organic to start. I'll just ignore that question. Oxygen and nitrogen are useful gases. We never talked about this. How can you separate oxygen and nitrogen? How so we can do this? Fractional distillation. What property allows us to do this? State the property of oxygen and nitrogen that allows these gases to be separated using. They have different what? Boiling points. Junaid, the Zoom link is on Tribe. On our Tribe, it's on, what do you call it? tribe.teachingcircle.one, that's the website. You have to enroll for the chemistry O-level course. There you'll get the link. Okay, dot and cross. I think this is straightforward. I won't try explaining this unless someone specifically asks for it. You won't find it on Noon. Yeah, IGCSE is cancelled in Pakistan, the paper 4. We're doing it for people who are not in Pakistan. Also, it's good practice. Yes. Oh, yes. Even paper 2 for Olaf is cancelled. Oh, that's why we have no one showing up. Oh, because no one's sitting for this. IGCSE is easier? I think IGCSE is more difficult. For one thing, the IGCSE paper, I keep confusing my numbers, but I think for 40 questions, you're allowed 45 minutes, the MCQ paper, whereas all our students are allowed 1 hour for the MCQ paper. So just by that, and I've found the quality of questions slightly more difficult for the IGCSE. Not that it's impossible, it's like 19-20, as we say in Urdu, which means 19-20. Difference, but not a lot of difference. If I pay you $19 or $20, you're not complaining too much. Like, I'm only off by $1, right? Because you're getting so much money anyway. That's the idea. Okay, this should be fresh in our heads. The graph shows the concentration of carbon dioxide in atmosphere over 60-year period measured in parts per million. Parts per million is amount of carbon dioxide molecules per every million molecules of whatever else it's mixed in, right? Parts per million, you probably see a lot of corona cases in parts per million, right? If you're following that thing. What do you call it? The worldometer. Coronaometer. I forget the website's name. Okay. Nice answer. Jot it down. Okay. Okay. Why is the increase carbon dioxide bad? There is an increase. Okay, why is this a global concern? Because the graph, why is this graph essentially highlighting a global concern? Because it's showing the, I'm abusing this yellow color. The concentration of CO2 is increasing. That increase in concentration CO2 is a greenhouse gas what's a good matching color here? Let's try this. This will probably look really bad actually. Let's try this. And contributes to global warming. If you haven't picked it up, each color for me is generally 1 mark, at least most of the time, unless I'm being forgetful or maybe I don't feel like it. And contributes to global warming, to the, I want to be fancy, to the global warming of the planet. I smell biryani. What's that? Name the process in carbon cycle by which plants remove carbon dioxide from the atmosphere. What is that process they refer to? It's the photochemical synthesis. I'm just being fancy. There's no such thing. Photosynthesis. Am I missing questions? It increases. That is a harmful gas, harmful for humans. Causes global warming. Why is it harmful? Because it's a greenhouse gas and it increases global warming. We shall move on. Oh my god, where's my organic? Oh, it's 9:52. I think I can take 5 more minutes. What is meant by electrolysis? 2 mark question. 2 marks. 2 marks. It is the breakdown or decomposition, breakdown of ionic compounds, molten or aqueous or otherwise, compounds by passing electrical current through them. Actually, I think I'll end it because my hand's hurting a lot. Why are inert electrodes used? So they don't take part in the reaction. Am I going too fast? Is the space good? I think I'm just answering questions. Part in, wait a minute. So they don't take part. 1 minute. This is O levels. It says IGCSE, Samia, the video. CFC depletes the ozone layer? Yes, it does. Why are you mentioning that, Amila? So they don't take part in the reaction. My hand's cramping up. The reaction. Okay. This is aqueous dilute sulfuric acid electrolyzed, dilute sulfuric acid. So essentially, what are the chemicals over here? It's H2SO4 and H2O. These are the 2 chemicals. When they ionize, they turn into H plus ions and sulfate ions. And for the other guy, they'll turn into, again, H plus ions and OH minus ions. Right? Now, between the 2 positive ions, what will go to the cathode? Well, they're both the same. So H plus ions will go to the cathode and get discharged, right? So what's produced when hydrogen is discharged? Hydrogen, not the ion, hydrogen gas. So you don't say hydrogen ion, you'll say hydrogen gas. Hydrogen. And between the two, which cation will go? Sorry, which anion will go? So the idea is sulfate is at the top of the least preferred discharge one, and all the way at the bottom you have OH minus. And OH minus is the most preferred of all anions, unless I'm making a very blunder. If not the most, like the second most, right? And OH ions are always discharged. So when OH ions are discharged, they form water and oxygen. But what do you end up seeing over here is just the oxygen coming out, not the water being produced. So you'll just write what? What? You will write oxygen. Write an ionic half equation for the reaction at the negative electrode. Negative electrode, hydrogen is going there. That's easy. H plus plus electrons give you H2, 2, 2. ठीक है, shall we end it here? I am literally dead. Did you guys enjoy this? Was this good? Was this educational? Give me some feedback. Was I going too fast? I think I was. But I think we explained most questions. I did do some commentary, but no one asked me questions in any detail except Binte, but she never got back. So I'm guessing she got it. She understood it. But thanks for joining. Thanks for coming. We'll continue this. Tomorrow we don't have a class, but the day after. I'll post the schedule on Noon and Tribe. I've just been very, what's the word? I want to say busy, and I have been busy, but I think you guys take priority. And so poor at managing my priorities, right? But I'll see you guys. I don't think I'll see you guys Thursday. I think you'll be with Sir Bilal, who will continue this and probably start a new paper. But yeah, okay, all right. Thank you guys. Bye-bye. Take care. Let's end it here. Thank you, YouTube. Thank you, people on Zoom. Well, it's just Miral and Hanan, but thank you, Miral and Hanan. Okay. Bye, YouTube. Take care.